I had a friend who did special effects for movies, and he needed to carry for a shoot something they made, which was really important, which was a briefcase scale nuke.
Right.
And it was a completely accurate briefcase scale nuclear bomb. And this was in the era when they asked you to turn on laptops. So when we went to security, they said, I can't tell what that is. Would you turn it on? So, we've seen machines.
Yes.
But what makes the machines? And so in digital fabrication, we're going down a roadmap from computers controlling machines, that dates back to 1952 NC Mill, to machines making machines. Next stage is not rapid prototyping, but rapid prototyping of rapid prototyping. Then putting codes into the construction of material, then program. So Will and Amanda showed you coding the construction of discrete materials in Ben, and then Amanda and Noah showed you programming the materials. But coming back closer, this is Nadia, who showed you the CT, and what she's working on is rapid prototyping of rapid prototyping machines. So Nadia, can you explain?
Yeah. So you haven't been upstairs to our big workshop yet, right?
Not yet.
No.
So we have a lot of machines there, which I use to make more machines. You know, self-replication, except that actually I'm the one controlling everything. So this is a small milling machine that was made on the big milling machine you'll see upstairs. So it makes circuit boards, can make its own kind of control boards. And the difference between this machine and maybe some of the other ones you've seen is this one is assembled without fasteners and made out of cutting boards.
So other machine company and ShopBot HandyBots were all based on this design of quick turn, snap together machine building. And this actually is a particularly useful machine. It lets you make PCBs and it lets you make molds for casting. So a precision construction tool.
Here's a PCB that you mill on a milling machine, for example. And this is a machine, this is the more James Bondy machine, where it is a pop-up, multi-purpose fabrication machine. So it pops up, and then here's your USB stick, and then I have different heads for it.
That you snap right onto the...
That you put them on this coupling here. So here's like a mill, so it becomes the same as this machine, or just like a regular 3D printer head for an FDM 3D printer.
Wow.
And then this one is a knife, so it can cut. For example, it's like a drag knife, so it can cut its own stickers.
Right.
And it's kind of,
And it fits as carry-on luggage.
not just as carry-on luggage, as your personal item.
It's that small.
So if you have different heads, right?
Right.
Each head needs different controls. So you need temperature control for this, or you need speed control for that.
Sure.
Or if you want to do liquid handling, you need a different controller. So do you have to design a controller ahead of time that can do everything, or can you just change the controller on the fly? In software, you just import libraries as you need different things. And so the control systems that I use are networked in that way, or we design control systems that are networked so that every time you change a machine, you can also change its controller, and on the fly you can modify the function of the equipment that you're using.
So this is one of those big steps to unpack. So in that machine, there's no file format, there's no G codes, there's no interpreter. Just every degree of freedom in the machine is a node in a real-time network. Then you make virtual machine controllers. So if you want to go from 3 to 4 to 5 axis or open to closed loop, nothing changes in the machine. It's like object-oriented hardware.
So you're decoupling the machine and its control software.
Machines today are like Fortran. It's all kind of baked in.
Right.
This is like the internet or object-oriented programming, where the machines are just degrees of freedom, and then you compose physical degrees of freedom with software degrees of freedom to quickly change the machine.
Or more practically, say you wanted to make like a 3D printer to make cups, right? And instead of making a 3D printer that moves like most of them do, which is X, Y, Z, like this, you want one that kind of rotates so that you can make a cup the way you throw a wheel, right? So you can start with like one platform that moves this way, and you add another one that moves up and down, so you can add like a head. I'm not actually going to connect these together, but you have like the 3D printing
she's explaining,
head.
Nadia's best buddies with the Shenzhen manufacturing ecosystem. So she sources custom motors with integrated lead screws with anti-backlash nuts.
These are actually from Durham, North Carolina.
Oh.
Yeah. These are Teflon coated fancy lead screws from.
And then you make them into these modules. And
so this one is like a linear one. This one is a rotary one. Here is a 3D printer head. So like you can imagine, you can assemble the mechanical parts of the machines.
And then it's all
it also makes sense why you need to assemble the controls part, because as you reconfigure the machine, you have to do different kinds of stuff. And And then, so I have all these fancy metal ones, but who is
So-
able to use those?
Ultimately, instead of building a machine and then figuring out the way that that machine gets controlled, you're building a system in which any machine can be controlled by any module that you need to direct.
But more than that, saying my lab has the laser cutter and the milling machine and the EDM, you just have degrees of freedom and effectors. And for
Right.
any one project, you compose them to do the project.
I see. Okay. Even bigger.
Not
than
touching your
components, it's
microphone,
machine
don't
by
worry.
machine.
Right. And so it's rapid prototyping of rapid
So
prototyping.
here's like a cardboard version, right? So say you wanted to do it really fast. Can you make a machine in a couple of hours as like your first prototype? So here's like a cardboard version for moving around this mirror so that you can move around a laser. And that's part of a kit. I'll show you a little video.
But
I
so
can
you
also-
have an actual mover in there. So this isn't a mock-up of a machine. It's a
No,
machine.
it's a machine.
It's both to teach machine building, but it's for rapid prototyping of things that have lower forces, like if you're just slewing a mirror to aim a laser beam. And so we've sent these all around the world to let beginners do machine building.
So it's laser cut. The cardboard is laser cut, so that's how you get the
right.
precision in the folds, and then it's laminated. This is my collaborator, James Coleman. So this is a laser cutter you'll see upstairs. It's
Okay.
quite large, but not that large. This is the network control system, so you're assembling the controls. This is how you assemble the cardboard. And here at MIT, we teach the class how to make almost anything. And then globally, we teach a version of that called the Fab Academy. And one of the 2-week assignments in Fab Academy is build a machine. And so they have these cardboard kits, which they use to build machines. And we teach it like over a video link, and then they locally in their Fab Labs then do their assignments.
Right.
And so these are all the machines that people build. So these are like drawing machines. This is a 3D scanner, so they put the iPhone as the end effector, and they have this platform on there. Or this is a coffee stirring machine.
Wow.
Very serious. This is some kind of light show.
But that's
this,
a multi-axis hot wire cutter,
Right,
more
right,
seriously.
right.
And these are all beginners, just making a machine.
Incredible.
Okay?
Yeah.
So rapid prototyping of rapid prototyping. For all the coverage of like
this is a
the
lathe.
rep or the maker bot,
Right.
it's transitional.
This
The
is
next stage
precision
is
ketchup extrusion.
the next stage is just you compose machines. And then I don't know if there's anything you can show. You know that modular workflow tool I showed you in the browser?
Yeah.
That's what we're also using to make the control systems for these.
Of course,
Because that's
right.
a real-time data flow. You start from the CAD, but it goes all the way through to the machine controller in that same environment. So you don't toss a file over the transom to be made.
Right.
Just
right.
in the design environment, it goes all the way through to the machine. In fact, we did a hook in SolidWorks, for example, where you can be designing in SolidWorks, and it just tucks directly into all of that. You never leave it, but you're in real time talking to the machine.
Amazing.
Yep.